Today we're going to talk about simplifying square roots and solving quadratic equations. The first thing, a square root is given by this symbol here, also called a radical sign, and the radicand is the number inside the square root. So if I look at this square root of 16 here, the radicand is 16. And then the square root of 16 would be 4, because 4 times 4, or 4 squared, is 16. So let's try another example. When simplifying radicals, the first thing we have to make sure is there's no perfect squares inside the radicals. There are no fractions inside a radical, and there are no radicals in the denominator. So what does it mean to have a perfect square inside of a radical? It means any factor that's a perfect square, such as 1 squared, 2 squared, 3 squared, 4 squared, etc. So the first one we're looking at is the square root of 88. What I do is I do a factor tree to break down to see if there are any perfect square factors in this square root of 88. So the factors of 88 are 8 and 11. Factors of 8 are 4 and 2. 4 is a perfect square because if I factor that down to 2 and 2, I have a pair of 2's. So we have a pair of 2's, a leftover 2, a leftover 11. I don't use the 4 or the 8 because it factored further. So 2 times 2 is 4, and if we take the square root of 4, we get 2, so I pull a 2 outside the radical. And inside the radical, I do 2 times 11, and 2 times 11 is 22. Therefore, if I simplify the square root of 88, I would get 2 radical 22. So if I look at the next one, the square root of 12 times the square root of 2, I'm going to multiply these two. So I get the square root of 12 times 2, which is the square root of 24. And now I would do the factor tree again. So factors of 24 are 12 and 2. Factors of 12 are 4 and 3. 4 is a perfect square again, so I have a perfect square. Square root of 4 is 2, because 2 times 2 is 4. I have a leftover 3, leftover 2. So what I do is I take our perfect square factor, which is 2 times 2, factor that out. Square root of that is 2. Times, well, my leftovers go back inside the square root, so 3 times 2 is 6. So if I were to simplify the square root of 24, I would get 2 radical 6. So then I go to the next one, which says I can't have fractions inside of square roots. So what we do is we actually take the square root of both the top and the bottom. And now I can't have a square root in the denominator. So I take the square root of 49, which it is a perfect square, it's 7. And now I can't have perfect square factors inside the top one, so I got to do the factor tree for the square root of 24, which once again we just did on the last problem. We got 12 and 2, 4 and 3, 2 and 2. I cancel out any factors that went further. I circle my pairs, box up my leftovers. I pull my pairs out. 2 times 2 is 4. If I take the square root of 4, I get 2. I put my leftovers back in the fridge being the radical sign. So I put my leftover 3 and 2 back inside the radical sign, and I multiply everything if I get multiple pairs or multiple leftovers. And then 2 times 3 is 6. So 2 radical 6 is what the square root of the 24 factored into here. So 2 radical 6 is in place of the square root of 24. And then, of course, I put that over 7 because that was the original problem. And that's our answer, 2 radical 6 over 7. The last one we're going to take a look at is the square root of 6/5. Once again, just like the last one, we can't have a square root or can't have a fraction inside of a square root. So we take the square root of the top and the square root of the bottom. Well, in the last problem, the square root of the denominator was a perfect square, so we just factored it out or simplified it, and we got a 7. Here, 5 is not a perfect square, so we have to do a different method, which is to get the square root out of the denominator. We call that rationalizing the denominator. To do that, we multiply by whatever is inside the radical on both the top and the bottom. This is basically like multiplying by 1, so it doesn't change the value. It's just going to change the way it looks. So the square root of 6 times the square root of 5 is the square root of 30. Square root of 5 times the square root of 5 is the square root of 25. And now we could simplify the square root of 25. And the square root of 25 is 5. So the only other thing we have to check is the square root of 30. Are there any perfect square factors? Factors of 30 are 3 and 10. 10 factors to 5 and 2. We cannot go any further. So I look at this 10 we factored further. So I got a 2, a 5, a 3. I have no pairs. So I would multiply them all back together and put them back in the fridge, and that would give us 30. So radical 30 over 5 is simplified. Now let's take a look at a couple of equations. How do we solve example B? We have 1/2 x squared plus 12 equals 40. First thing we have to do is subtract the 12. We're trying to isolate the x here. So we subtract the 12, we'll get 1/2 x squared equals 28. Now we got to get rid of the 1/2. So we're going to multiply both sides by 2. And 2 and the 1/2 will cancel out. So we get a 1x squared, or just x squared, equals 28 times 2, which is 56. And then, of course, the last step would be to get rid of that squared, which is to do the square root. And a square and a square root will cancel each other out. So we'll just have the x by itself. And then we just have to figure out what does 56 factor into. Well, we know 28 times 2 gave us 56, so 2 and 28 are factors. 7 and 4 are factors of 28. 2 and 2 are factors of 4. So we got a pair of 2's. So that means we're going to pull a 2 on the outside. We got a leftover 2, got a leftover 7. And remember, the 28 and the 4 factored further, so we don't use that. We multiply our multiple leftovers to get a 14 inside the radical. And when we solve an equation that has an x squared here and we take the square root, there should always be a positive or negative answer. So it's plus or minus 2 radical 14. And that's the answer we would. Let's try letter D. So when we have this, it's a little bit different because we have parentheses around whatever squared. So what we have to do is get the parentheses by itself before we can get the x by itself. In order to do that, we're going to add 8. So the 8's cancel out. We get 3 times the quantity of x plus 5 squared equals 48. And now we're going to have to get rid of this 3. So we'll divide both sides by 3. And when we divide by 3, the 3's cancel out. We get the quantity of x plus 5 squared equals 48 divided by 3, which is 16. Now, if we're looking at the left side, everything in the parentheses is squared. So now we have to get rid of the squared by taking the square root of both sides. So a square root and a square will cancel each other out. So we'll get x plus 5 equals, and the square root of 16 is 4. But remember, whenever we take the square root here in an equation, we should get plus or minus 4. So at this point, we just have to get rid of that 5 next to the x. To do that, we're going to subtract 5 to both sides. Now here is where we have to subtract 5 to a positive 4, and we have to subtract 5 to a negative 4. So we're going to get 2 different answers because it's plus or minus 4, so 4 minus 5 or negative 4 minus 5. 4 minus 5 is negative 1. Negative 4 minus 5 is negative 9. So we actually get 2 answers, one being negative 9 and the other being negative 1. And that